He's wearing a mic, so we can pick up on the camera there.
All right.
Perfect.
Good morning. I'm Paul Sauter, founder and chief scientific officer of EquiSeq. We sell genetic tests for horses. So today I'm going to tell you how we got started, what we do, and where we're going. So here's how we got started. In 2000, I moved to the Jackson Laboratory in Bar Harbor, Maine, which is the center of the universe for mouse genetics. So mice and humans and all other mammals have the same set of genes. Every living thing on Earth is descended from a single common ancestor, and they all use the same method of encoding genetic information. So when I was at the Jackson Laboratory, the Human Genome Project was completed. That's a human. And that gave us the complete DNA sequence of the human genome. And they soon followed by doing mice and many other animals. So we now have the source code for human beings and hundreds of other species. So early in 2015, we started EquiSeq to take advantage of an opportunity in horse genetics. So human genetics is really, really crowded, and it's dominated by big players and lots of money. So a startup can't play there. Similarly, animals of agricultural importance, like cattle and pigs and sheep and chickens, that's also dominated by large players and a lot of money. But think about it. We don't need horses to plow our fields because we have tractors. We don't need horses to get around because we have cars. And we don't need horses to haul cargo because we have trucks. So it looks really bad for the feds to use your tax money to subsidize the sport of kings. That's the opportunity. So in March of 2015, we started EquiSeq to take advantage of that opportunity and develop genetic tests for inherited diseases in horses. So that's how we got started. Let's tell you what we do. Whoa, that's bad. What happened? Yeah, that's our core scientific team. So a veterinarian and 3 PhDs with decades of experience in genetics, genomics, and bioinformatics. So when we joined EquiSeq, we joined the largest laboratory that any of us had ever been a part of, Facebook. We found a Facebook interest group for people whose horses have a muscle wasting disease. And these people were crying out for help. So we had no problem getting health information and DNA samples to start our analysis. Within 6 months of starting the company, we had found the first genetic variant associated with the muscle wasting disease. Our current offering is a panel of 4 genetic tests for different genes that predict the onset of this muscle wasting disease. It's very easy for horse owners to test their horses. They pull some hair, mail it to us, and they get the results back electronically. This is Maverick. Maverick is a paint horse owned by Charlotte, and he was one of the first horses to test positive for the P2 genetic variant, which is associated with muscle wasting disease. Now we're on Facebook a lot, and one morning Charlotte posted that she found Maverick lying down in the snow. And 4 big guys from next door came over to stand him up, but he couldn't stay standing. By the time the vet got there, Maverick was dead. There is no treatment or cure for this muscle wasting disease. It has to be bred out, and in order for that to happen, there has to be a genetic test. So what's wrong with Maverick and horses like that? A racehorse can go from 0 to 40 miles an hour in 2 strides. So how's that possible? What powers these animals? Over half of the mass of a horse is muscle. Muscle is nature's nanotechnology. It takes chemical energy in the form of ATP and converts it into mechanical energy. So a muscle fiber is made up of a bundle of units called myofibrils. So this is an electron micrograph of a myofibril. You can see these 2 dark bands, those are called Z-discs. They're very protein-dense structures, a lot of protein in them. And radiating out from them, you see thin filaments overlapping thick filaments in the center of the structure. So when a muscle contracts, the thick and thin filaments slide with respect to each other and pull the Z-discs closer together, and then the muscle contracts. So the genetic variants that we have discovered are defects in genes that encode proteins that are structural components of the Z-disc. So these defects weaken the Z-disc and they weaken the muscle. So that's how we got started in what we do. Let me tell you about where we're going. There are 3 stages in the commercial rollout of a genetic test. In the first stage that we call early access, we give horse owners genetic test results without even necessarily telling them what the genes are. And the next stage is publication in a peer-reviewed scientific journal. And that's important because then veterinarians can endorse our tests. And we're nearing that milestone. The final stage is the requirement for these genetic testings by breed organizations like the American Quarter Horse Association. That is a long way off for us, and I'd be glad to discuss that during Q&A why that is. So here's the basic business model we started with. We make discoveries, and then we secure those discoveries through patents, and then we sell genetic tests directly to consumers. So we're currently engaged in direct sales at a modest volume. If we were to get 10 or 20 times the volume of tests we have right now, we'd have to hire a bunch of people to do order processing and customer support. So this isn't really scalable. So a more scalable business model is licensing. Here it's the same process. We make discoveries, we secure those discoveries through patents, and then we license those tests to other test providers. We just closed our first licensing deal with the Center for Animal Genetics in Germany. That deal was announced at 7 a.m. this morning, so you guys are hearing it first. That's our first licensing deal, and I'm sure others will follow. This is obviously scalable because we can continue to be an R&D company and pump this stuff out. The final business model is a trade secret model. So here we make a discovery, either on speculation or as a contractor, and we provide exclusive access to that discovery as a trade secret to a single buyer. And we hope to close a deal of this kind by the end of the year. So this is the rest of our team. Lexi Palmer, our former CEO, Alex Hofnes, our current CEO, Kirsten Dimmler, our bioinformatics analyst, and Jamina McAteer, our data wrangler. So I've told you how we got started, what we do, and where we're going. That's EquiSeq. Join us.
Where are you based?
Albuquerque, New Mexico. And we have like distributed things everywhere. So our molecular biologist is operating out of a vet clinic in Asheville, North Carolina. DNA sequencing, we outsource that. So we have a couple firms we use for either whole genome sequencing or Sanger sequencing. So I actually don't do any wet lab work at all. I just do bioinformatics and computer stuff and contact and most others.
So about you mentioned becoming a requirement of the breed association.
Yeah.
So what is that process?
Well, okay, so there's two aspects of that. First, I'll tell you what the process is, and second, I'll tell you what the barrier is. So the process is there's a scientific review board at the breed organization that says yes or no, this is a valid test and this is important and we should require it. And I don't think there's going to be an impediment there because our academic collaborators are fully confident in these tests and are participating in the publication process. So I don't think there's going to be a problem getting through scientific review once we've published. The bigger problem is that those breed organizations serve their membership. And if the members don't want these tests, the breed organization is going to have a really, really hard problem pushing it. So one thing, if they just, let's say, 2 years from now said, okay, these tests are required. If you want to register your horse through AQHA, we're going to require the test. People will say, then I won't register through AQHA and I'm dropping my membership. And the problem with that is the onset of these diseases is late in the horse's career. So typical age of onset is 7 to 10 years. That's typically after a horse has started breeding. So this is the only way to get rid of it is to require the test. But there are stallion owners that are getting a $3,000 stud fee whose stallion has sired 1,400 offspring. That's $5 million. We know one of those that's positive by inference from his progeny. So that person is going to go out of business, and that's their only source of income. So they will be at every AQHA meeting fighting that until we die, or they quit, right? One or the other of us is going to go, right? So there's going to be massive resistance. The incidence of these variants is high in quarter horses. So we don't have really unselected data, but when we've looked at a number of herds, and as many as a quarter of some quarter horse herds have one or more of these variants. And so you're talking about a forward-looking breeder can take the risk that maybe our science isn't 100% solid, clean up their herd now while they still can, and they can be producing clean horses. Everyone else can take the position, I'm going to wait until I'm required to do this, either required by the breed organization or required by the buyers who won't buy an untested horse. So we know what the future looks like in our view, and other people have a different view of the future. So we'll see who prevails.
So what is the age at which a racehorse generally retires?
Okay, so for thoroughbreds, that's 3 years. There's a fairly high incidence of these in thoroughbreds. So you have to understand that a horse changes hands many times in its lifetime, right? So from the standpoint of current breeders, many of them have just said to us, once I sell a horse, it's not my problem anymore, right? And until a large number of buyers insist on having these tests done, nothing will change. So forward-looking breeders can advertise, these are clean. For thoroughbreds, it's irrelevant, right? Because thoroughbreds' race career basically ends in 3 years. Then they're put out to stud. And so it doesn't matter if they have this, their life will be a little bit shorter, but they're not being worked, right? So for quarter horses, it's a different story. I mean, barrel racers can go, 15, 20 years as barrel racers and have a great career and earn a lot of money. So it is very much in their interest to clean it up, and there's a very high incidence of one of these in barrel race quarter horses. So it's different by breed and by what the horse is doing. But thoroughbreds also there are retired racehorse projects. So thoroughbreds can do dressage, they can do eventing, they can do all kinds of things as a second career after racing. And it's in the interest of thoroughbred breeders to build horses that don't have these defects. Yep.
Thanks for the presentation. What is your information strategy or marketing strategy to try to accelerate this process of changing the norm within the community to say that this is something that people want to have?
Well, so the first step is going to be publication in a peer-reviewed scientific journal, because until that happens, if you go to a vet and you say, this is what we found, they say, that's interesting, please let us know when you get the paper, right? Because they don't want to even talk, because it's an internet rumor, right? It's not science, and they're correct in doing that. You don't want your vet to change what they're doing on the basis of like some guy that just talked to them, right? So it has to go through scientific review. So that's the first thing. So a number of people have said, why don't you make videos? Why don't you put some money into marketing? We have put zero into marketing until now. And probably our first efforts will be after peer-reviewed publication. So we're actually pretty surprised that Germany signed the deal that it did. They wanted an exclusive for Europe, and they knew if a publication happened, they would never get that. So they jumped in early, and they're going to gain an advantage because of it. Yep?
Do you have any legislative options to mandate testing of this?
No. I mean, because like right now, you can go to a kill pen and buy a discarded quarter horse for maybe $300 and make it into dog food, right, in Mexico. So there's really kind of no regulatory, I mean, they don't have kill pens in the United States anymore, but there's no particular requirement for anything in horses. I mean, if you want to put a drug in a horse, you need USDA approval. Genetic testing isn't regulated at all, and because horses are unimportant in the United States, it's unlikely that there will be any legislative push to push for testing. Now, the matter is different in some European countries. So in Scandinavia, several countries have a very ill-considered law that makes it illegal to breed a horse that has a genetic defect. I am probably the only person in this room whose genome has been sequenced. Am I correct?
No.
No? Oh, who else has been sequenced? Full sequence or 23andMe?
Yeah. SNPs.
SNPs? Anybody full genome sequence? Okay, so I'm still correct. But anyway, so the thing is, once you have your even 23andMe, right? So in 2012, when I was sequenced, there was a 90% chance that you'd get a medically actionable finding from being sequenced, and I got several, right? So it's something you could do about something about to improve your health, right? So there is no human being, and I'm sorry for telling you this, in this room that doesn't have a genetic defect of some kind, right? So the problem is in horse, let me compare that to human. In human right now, there's a test for 5,000 inherited genetic disorders. In horse, when we started, there were tests for 16, right? So don't tell me that horses are free of genetic defects. We just don't know anything about it because there's no funding to discover them. So a law that says it's illegal to breed a horse with a genetic defect means that it's illegal to breed a horse. They all have genetic defects. It's just a matter of which one. So, but no law like that's ever going to be passed in the United States. No way.
Yep. Is the gene passed through both male and female?
Yes.
Is how many tests would it take before the breeding out could occur?
Well, so The problem is there's 20,000 genes in a horse, and we're testing 4 of them, right? So you're breeding a horse for a specific task. So if you have a champion barrel racer, and he's racking up the money, he's got everything involved to be a barrel racer, but he's also got one of these, you don't want to say, let's pull him out of the breeding pool. You say, let's test the mares that we're crossing him to, and we're going to try to carry over some of his performance characteristics, which depend on many, many genes. And we're going to try to salvage what's good about this horse. And over time, we're going to get rid of the defects. So to answer your question accurately, if the stallion has one copy of one gene, so it has one good copy, one bad copy, and that's crossed to a clean mare, half of the offspring will have the bad gene, right? And so it's a coin toss every time you breed. So if you say we want to eliminate it in one generation, you can say we'll only use clean mares, and half the offspring are not going to be useful for our breeding program after that. But we could eliminate it in one generation. That's not going to happen. But because it's a balance of the positive traits that you're selecting for and these negative traits. So minimally, you'd like a breeder to test the mares, because there's a very unfortunate practice in quarter horses. If a mare is useless for any other purpose, they say, well, at least she can serve as a brood mare. And that's how these genetic variants have been driven up in frequency. A horse a mare that's lame and that has one of these diseases, they'll still use it to breed, because they say, I put money in this horse, I want to get something out of it. And what they're getting out of it is misery for quarter horse owners. All right, complicated issue, yeah.
You said that there was a couple different instances that they can test positive for.
Right.
How many instances you said you were testing for?
4 different genes, yeah.
Okay.
And we're discovering new ones. So what happens is when we did our initial set of testing, we get people that said our horse is still symptomatic, but it tests negative for all its variants. We say, can we get a blood sample? Can we do whole genome sequencing? So we have this residue of horses that have other genetic variants that are currently in development. So we're pretty optimistic that some of those are going to be commercial tests within a year, because some of them look very promising, which from a genetic standpoint means they're very bad news.
Now, if it was a cost for a test?
$250 to get, or $249 to get the panel.
That's it. I mean, that's it.
That's cheap, right? So by way of comparison, let's take the extreme end. For thoroughbreds, it costs $60,000 a year to maintain a thoroughbred and bring it to the point of a 3-year-old. So by the time a thoroughbred is raised for the first time, it's $180,000. Speaking of numbers, can anyone tell me what the most that was paid ever for a thoroughbred that won the Kentucky Derby? After it won? Come on, put up a bid, anybody.
$2 million.
$2 million, $20 million. Anybody else? $60 million. $60 million for a horse.
For one horse?
For one horse.
Which horse?
ROI was not so good on that one. So for quarter horses, it's a lot cheaper, right? But still, like if you're a breeder, and my pitch is if you're forward-looking, you want to build a program that pumps out clean horses, because we have people who have already started with that, and the first guaranteed clean foals are going to hit the ground next summer, and those people are going to get a premium for those horses. And that's going to get back to the breeders. You know, I should have done this a year ago, I should have done this 2 years ago, and that's what we're hoping is going to happen. So that publication in a peer-reviewed journal for what the defects are.
So how far away are you from publication?
So what's happening is one of our academic collaborators is opening up a study probably this month where they're going to recruit up to 2,000 horses with very detailed health information. They have our tests. They've been operating our tests in their lab for about a year. I think it'll be pretty fast to bring that to publication. So I'd say within a year of this month, we'll have a peer-reviewed publication on that set of variants. We have some others that are a lot more straightforward that are in the pipeline, and we might actually end up publishing a minimal paper on one or more of those prior to that. So sometime in the next year or so, we'll have our first publications. Yep.
Could you just comment on the longevity of the model? I mean, so hypothetically, if what you're testing for is hereditary genetic diseases, eventually you'll test yourself out as a market.
Right.
And so...
If everyone's rational.
Right.
Exactly.
And I'm curious, how do you see this as a parallel to 23andMe, where their core focus now is both on scientific discovery, but then also in creating a social network of
Right.
individuals and genealogy. and things
Well,
like that.
I love that you've mentioned 23andMe. Does everybody know about the latest deal?
Yeah.
300 million, right? For cooperating with a pharma. Their prior deal was 60 million from Roche just for Alzheimer's targets, right? So the question is really about what's an exit, right, for EquiSeq. And biotech companies tend to be acquired for their data. So just as 23andMe is selling off chunks of IP, we could be a target for Zoetis or Boehringer Ingelheim or anybody else that has a veterinary division, a pharma with a veterinary division. The other thing that we're going to do in the medium term is, right now the tests, I don't know how technical anybody is here, the tests are done by PCR amplification and Sanger sequencing or allele-specific quantitative PCR, right? If you're not technical, don't worry about that. But it's one gene at a time. Now what 23andMe does is a hybridization array on a chip. There hasn't been any point to developing a horse hybridization array because there were too few disease genes, but our long-term goal is, or medium-term goal is to develop a hybridization array for horse. That way, even if people infringe our patents, they can't compete with us on price and they'll have to just license our chip. Yeah, so that's the medium and long-term strategy.
Any other questions? Okay, so what can we do as a 1 million folks community to support you?
Wow. So the reason I'm here is, it's great to talk to a fresh audience that's never heard anything about EquiSeq. And what I'm trying to do is make sure that the small amount of science that's presented is clear. So if you don't know anything about biological science, did what I say make sense? You're probably all much sharper on business stuff. So like, does the business thing make sense? And is this message being effectively communicated? Right. That's the one thing. And the other thing is, I know you people know people, so I would love to get connected to your networks of people that might be in the horse industry or might know something about the industry. Because I am not a horse person, I'm a recovering academic. I don't know anything about horses. I mean, I've ridden horse in decades. So connecting me with actual horse people would be really a wonderful outcome. Thank you.
Perfect.